Ready to move your GitHub authenticated FastMCP server from local testing to production-grade security. You'll see exactly how to configure persistent encrypted token storage with Redis while keeping sensitive credentials properly secured through environment variables. This production setup ensures your OAuth tokens survive server restarts without compromising security.
Import auth. From FastMCP, import FastMCP. From FastMCP server, auth providers, GitHub import GitHub provider. From key value, AO stores, Redis import Redis store. From key value, AO, wrappers, encryption import Fernet encryption wrapper. From cryptography, Fernet import Fernet. Hash production setup with encrypted persistent token storage. Auth provider equals GitHub provider. Client ID equals auth23 ly abc def guy jk lmn. Client secret equals GitHub pat. Base URL equals https:// your production domain, com. Hash production token management. JWT signing key equals OS. Environ, JWT signing key. Client storage equals Fernet encryption wrapper. Key value equals Redis store. Host equals OS, environ Redis host. Port equals int OS, environ Redis port. Fernet equals Fernet, OS, environ storage encryption key. MCP equals FastMCP. Name equals production GitHub app. Auth equals auth provider.
This implements the OAuth proxy pattern with encrypted persistent storage, bridging GitHub's traditional OAuth flow with FastMCP's authentication requirements. The pattern acts as a translator between GitHub's OAuth 2 implementation and FastMCP's token-based authentication system, handling token exchange, validation, and secure storage automatically. What makes this distinctive is its ability to maintain stateful authentication across server restarts while keeping sensitive tokens encrypted at rest. The architecture separates authentication concerns into 3 layers: the OAuth provider handling GitHub's protocol, the encryption wrapper securing tokens in transit and storage, and the Redis backend providing persistence. This layered approach allows each component to focus on its core responsibility. GitHub handles identity verification, Fernet manages encryption, and Redis provides durable storage, while the FastMCP server remains agnostic to these details. The JWT signing key ensures tokens remain valid across restarts, while the encrypted storage prevents exposure of sensitive credentials. This pattern solves 2 critical production challenges: maintaining authentication's state in distributed systems and securing OAuth tokens against breaches. Without it, you'd need to re-implement OAuth flows manually and handle token persistence, which introduces both complexity and security risks. The trade-off is operational overhead for Redis and key management, but the benefit, secure, restart-resilient authentication, justifies this for any production deployment handling sensitive user data. Let's break it down line by line.
Import auth.
Imports the auth module for environment variable access, critical for production configuration, as it loads sensitive values like encryption keys and Redis credentials from the environment rather than hard-coding them. This follows the 12-factor app pattern for secure configuration management.
From FastMCP, import FastMCP.
This imports FastMCP, the core class for building AI-callable tool systems. It handles the heavy lifting of exposing Python functions as tools, managing authentication, and routing requests to the correct implementations.
From FastMCP server, auth providers, GitHub import GitHub provider.
This imports GitHub provider, FastMCP's built-in OAuth handler for GitHub authentication. It manages the OAuth flow, token exchange, and user validation, eliminating manual auth boilerplate.
From key value, AO stores, Redis import Redis store.
Imports Redis store and a sync-compatible key-value store implementation using Redis. This handles persistent token storage in production, replacing volatile in-memory solutions. The async interface prevents blocking during authentication flows.
From key value, AO, wrappers, encryption import Fernet encryption wrapper.
This imports Fernet encryption wrapper, a transparent encryption layer for key-value storage. It automatically encrypts data before persistence and decrypts on retrieval, ensuring sensitive tokens remain protected at rest while maintaining normal Redis operations. This is the wrapper pattern for adding security without changing storage behavior.
From cryptography, Fernet import Fernet.
Imports Fernet from cryptography, a symmetric encryption implementation for secure data protection. This provides the cryptographic primitives needed to encrypt sensitive tokens before Redis storage, preventing exposure if the database is compromised.
Hash production setup with encrypted persistent token storage. Auth provider equals GitHub provider.
This instantiates the GitHub OAuth provider for production authentication. It handles the OAuth flow, token exchange, and user validation against GitHub's API, while the configuration below ensures secure token persistence.
Client ID equals auth 23 ly abc def guy jk lmn.
This is the OAuth client identifier for GitHub's OAuth flow. It uniquely identifies your application to GitHub's authorization server, enabling the initial authentication handshake. Always keep this value secure, as it's tied to your production domain.
Client secret equals GitHub pat.
This is the GitHub OAuth client secret, authenticating your app with GitHub's API. It prevents unauthorized access by verifying your application's identity during the OAuth flow. Never commit the full secret to version control. Use environment variables or secret managers.
Base URL equals https:// your production domain, com.
This sets the production domain for OAuth redirects and API endpoints. Required for GitHub OAuth to work correctly in production, it ensures all authentication flows return to your deployed application rather than localhost. Without this, users would hit 404s after GitHub redirects.
Hash production token management. JWT signing key equals OS. Environ JWT signing key.
This sets the JWT signing key from environment variables, ensuring secure token generation. Environment variables prevent hard-coding secrets in source code, while JWT signing enables stateless authentication for the GitHub OAuth flow.
Client storage equals Fernet encryption wrapper.
This wraps Redis storage with Fernet encryption, implementing the decorator pattern for transparent data security. All tokens stored in Redis are automatically encrypted at rest, preventing exposure if the database is compromised. The wrapper handles encryption-decryption seamlessly, so the application code stays clean.
Key value equals Redis store.
This instantiates a Redis store, the persistent key value storage backend. It handles token storage across server restarts, replacing volatile in-memory solutions. The Redis connection details come from environment variables for production security.
Host equals OS, environ Redis host.
This pulls the Redis server address from environment variables, enabling secure configuration without hard-coding sensitive hostnames. Environment variables are the standard pattern for production secrets, allowing different deployments to use different Redis instances without code changes.
Port equals int OS, environ Redis port.
This converts the Redis port from environment variable string to integer. Environment variables are always strings, but Redis requires an integer port, so this ensures type safety and prevents connection errors. This closing parenthesis terminates the Fernet encryption wrapper initialization, completing the nested configuration of the encrypted Redis storage. It finalizes the token storage setup, ensuring all authentication data is both persisted in Redis and encrypted with Fernet before being written to disk. This pattern of nested initialization is common when composing layered services like storage with encryption.
Fernet equals Fernet, OS, environ storage encryption key.
This initializes Fernet symmetric encryption using an environment stored key. It ensures all tokens in Redis are encrypted at rest, preventing exposure if the database is compromised. The key comes from environment variables, enforcing security through configuration separation. Closing parenthesis terminates the GitHub provider configuration. This finalizes the production-ready auth setup with encrypted token storage and JWT signing, ensuring secure authentication flows. This closing parenthesis finalizes the GitHub provider configuration. It completes the production-ready auth setup with encrypted token storage, ensuring all required parameters are properly encapsulated before being passed to FastMCP.
MCP equals FastMCP. Name equals production GitHub app. Auth equals auth provider.
This instantiates the FastMCP server with production authentication. The auth provider parameter wires up GitHub OAuth with encrypted Redis token storage, completing the secure tool execution pipeline. This is the final step before exposing tools to AI models. Production-grade OAuth pattern. This GitHub provider configuration demonstrates FastMCP's production-ready authentication pattern, where JWT signing keys and encrypted Redis storage work together to persist sessions across server restarts. The Fernet encryption wrapper is mandatory for production, as plaintext token storage violates security best practices. Proper environment variable management separates secrets from code while maintaining deployment flexibility.
The token that never rests becomes the session that never breaks.